Question number 2b asks us to solve 8 sine cubed of x over 3 minus 6 sine x over 3 equals 0. So first thing I'm going to do, since it's a cubic function, I'm going to factor out the common factor of sine, and I'm going to take out the 2 as well. So this part here then is a factor, so it's going to give me a solution. So I end up with sine of x over 3 equals 0. 0, it's sine, so it's vertical, so it's on this x-axis here. And those are the two positions that give me the solutions. So I have x over 3, it can be equal to 0, and I have x over 3, and that could be equal to pi. Still need to solve for x, so I get x is equal to 0 here, and here I get x is equal to 3 pi. Okay. So now, because this is a horizontal compression and I need all the solutions, I need the repetitions, but I need to know the period of these repetitions. So this 3 is going to be my horizontal, in this case it's an expansion. So that makes my period 6 pi. It's going to be a horizontal expansion by 3, so my period is 6 pi. So then to get all the repetitions in, I can do this, n times 6 pi. So I start at 0, that repetition happens at 6 pi, and then at 12 pi, etc. This one starts at 3 pi, and the next one's at 9 pi, 15 pi, 21 pi, etc. So we do this for all real numbers. We don't need to find individual solutions for that. Okay, so we've dealt with that part. I now need to solve for this factor. Okay, so I'm going to solve for that factor. So I get sine, since it's a quadratic, I could try to factor this, but really I can just solve directly for sine. So I'm going to get sine squared x over 3 is equal to positive 3 over 4. Solving for the sine, I'm going to square root both sides. And when I square root, I have to remember to get the plus minus. It's going to be the square root of 3 over the square root of 4, which is 2. So then I have 4 solutions in this. So if I draw my circle, the root 3 is alongside of the 30-60 triangle. So the positive is going to end up over here and here. The negatives are going to end up down here and down here. Now, that root 3 represents the long side. So I have 4 solutions. So x over 3, that could be equal to the quadrant 1 angle of pi over 3. Okay, it's a bigger angle, so it's going to be the 60 degree or pi over 3. And then I have a quadrant 2 angle. That's going to be 2 pi over 3. I have a quadrant 3 angle. Call that 3. This is going to be equal to 4 pi over 3. And then my quadrant 4 angle is going to be 5 pi over 3. So this factor gives me 4 solutions. I still need to solve for x. So x is equal to pi. X is equal to 2 pi. Here, x is equal to 4 pi. And lastly, x is equal to 5 pi. Those are all my primary solutions. I need it for all real numbers. And I know these repeat every 6 pi because of that horizontal compression. So this is going to be pi plus n 6 pi, 2 pi plus n 6 pi, 4 pi plus n 6 pi, 5 pi plus n 6 pi. Okay, so those are the 6 solutions and all their repetitions. And I can leave my answer like this. This is perfectly okay. However, you may notice that the solutions are at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and the next one's going to be at 6 pi based on this repetition. So in fact, we can actually simplify this solution. They're happening every pi. So starting at 0, they're just going to happen every n pi. And this can be another way to express it. It's actually much more a compact way to express all 6 solutions because we just combine them into one solution just happening every pi. Okay, so we can do it either way. Both ways are perfectly valid, but this way is definitely more efficient, is maybe a better way to put it.